Hey guys, this is the Spiral Review for Spiral 16. We're going to go through some of these problems to help us get a better idea of what's going to be on the spiral. Okay, first up, I've got 6 to the n plus 2 is equal to 1. Okay, I know I've got to, given we're in exponential equations land, we're not using logs. I've got to write 1 as a power of 6. So this is going to become 6 to the n plus 2 is equal to 6 to the 0. Leaving me with n plus 2 is equal to 0, or n is equal to negative 2. We'll look at number 3. 64 here. I've got 16 here and a 1 over 64. I kind of like the idea of transferring all these to a power of 4. So that become 4 squared. This would become 4 to the third and negative 3n minus 3. This would become 4 to the negative third, 2n minus 2. Okay? I can also do some exponent rules here. So it'd be 4 to the 2 minus 3 times minus 3 is negative 9, so that's plus 9. And 3 times negative 3 is negative 9, so it's minus negative 9 is plus 9. Okay? And on the right side, we're going to have 4, negative 3 times 2 is negative 6n, and negative 3 times negative 2 is plus 6. Okay, now we're looking at 11 plus 9n is equal to negative 6 plus 6. And I forgot an n there. I'm going to add 6 into both sides, so 15n is equal to, and minus 11 to both sides. 6 minus 11 is going to be negative 5. That means that n is equal to negative 1/3. Similarly, I could look at problem 4, and that looks like everything's going to be in base 5. So we get 5 to the negative 1 the negative 3p times 5 squared to the 3p is equal to 5 to the negative 3. Okay, I'm going to do some exponent rule work here. So we get 3p, and then multiplying means plus. 2 times 3p is going to be 6p, and that's 5 to the negative 3. So that means that 9p is equal to negative 3, and p is equal to negative 1 over 3. Next up, we got to do some evaluation of logs. I'm going to start off with log base 7 of 343. Well, I know that 7 to the third is 343, so this is equal to 3. Number 6, log base 3 of negative 243. Well, 3 to the 5 is 243, okay. 3 to the negative 5 is 1 over 243. There's no way for me to make an exponential expression to get to negative 243 with 3 as a base. This would be no solution or undefined. Number 7, log base 3 of 243. Well, we just so happen to have done this. 3 to the 5 is 243, therefore this is 5. Number 8, log base 3 of 9. Well, since 3 squared is 9, the answer to this is 2. We're writing in exponential form. Okay, there's my base. 11 squared is equal to 121. And 5, there's my base, to the 4 is equal to 625. Writing in terms of logarithmic form, here's my base, so log base 17 of 101 is equal to p. And log base 4 of 1 over 64 is equal to negative 3. Those are just rearranging based on the form that we know. Now we got some log properties. The first 4 we're asked to expand, and then we're asked to condense. First one, we're dividing here, so this is going to be log u minus log v. Second one I'm going to rewrite as log of a to the 1/3, and then I'm going to bring that out front. 1/3 log of a. For the next one, I'm going to do this in a couple parts. I'm going to probably distribute that 5 to this piece, guys, on the inside. And we get log base 8 of x to the 20 over y to the 5. And that's going to end up being log base 8 of x to the 20 minus log base 8 of y to the 5. I can bring those powers down, and we get 20 log base 8 of x minus 5 log base 8 of y. And we're done. 16, we've got the natural log of xy cubed all to the 6. I could do this the same way I just did 15, but instead I'm going to bring that 6 down first just to see what that would look like. So we get 6 ln of xy cubed, which I can break up with addition and get 6 ln of x plus 6 ln of y cubed, and finally bring that power down front. 6 ln x, 6 times 3 is 18, 18 ln y, and I'm done. Condensing, if I'm adding two things, the same as multiplying them, so that'd be log of xy. For 18, I'm going to convert this to 1/3 log x, bring that power up. We get log of x to the 1/3, totally acceptable answer. It's also lovely if you wanted to write log of the cube root of x. Speaking of the cube root of x, I'm going to deal with that 3 times here, because this could be written as 1/3 log 6, 1/3 log y, and 1/3 log 6 of x, of z rather. So this ends up being the log base 6 of the cube root of x plus log base 6 of the cube root of y plus log base 6 of the cube root of z, which combines to make log base 6 of the cube root. We only need 1 for all three, x, y, and z. Number 20, I'm going to bring my powers up first, and we get ln of x to the 12 minus ln y to the 6. Subtraction means division. This becomes ln, and I'm going to have the positive one, x to the 12 on top, y to the 6 on the bottom. Now we've got to solve some equations using logs. In some of these cases, we'll have extraneous solutions, so we got to check for that. But we're going to look at a variety of different ways to do this. Okay, in general, a good rule of thumb, especially if we only have one exponential, is to get that piece by itself. So I'm going to start off by adding 9 to both sides. And I get 5e to the 1 minus 3v is equal to 6. Divide both sides by 5. We get e to the 1 minus 3v is equal to 6/5. I'm going to convert this to a log equation. In other words, I'm going to take the natural log of both sides, is another way to say that. But we get 1 minus 3v is equal to the ln of 6/5. And finally, I'm going to solve for v. I'm going to subtract 1 from both sides and divide by -3. So I'm going to end up with ln of 6 over v minus 1 over -3 is equal to v. That's my final answer. Looking at 22. Again, I'm going to get that exponential part by itself first. I'm going to minus 8, then divide by -7. So if I minus 8 from this guy, we end up getting negative, I can't think right now, 65. That sounds good. Over 7. That's equal to 9 to the 2a plus 5. Negative 65 over 7 does not go cleanly, so we're going to leave it as that. Let's convert this to a log, or take the log base 9 to both sides. We get log base 9, by the way, this should be positive, of 65 over 7 is equal to 2a plus 5. Minus 5 to both sides, divide by 2, and I get log base 9 of 65 over 7 minus 5 over 2 is equal to a. Okay, looking at 23. We're going to minus 9 to both sides. We end up with log base 2 of n plus 3 is equal to negative 1. I'm going to convert this to an exponential. So we get 2 to the negative 1 is equal to n plus 3. So that's a half is equal to n plus 3, which means that n is equal to negative 5 over 2. If I were to plug that back in, we end up getting log base 2 of negative 2.5 plus 3 is a half, plus 9 equals 8. So that's negative 1 plus 9 is 8, so that worked. That is not extraneous. You don't have to check this on the exponentials, you do have to check this on the logs. Okay, I'm going to make an assumption that this stops here because they do not indicate otherwise, and that's an assumption that I need to make. So I'm going to minus 4 to both sides, and we get log base 8 of negative 9v is equal to 3. So we get 8 to the third is equal to negative 9v. 8 to the third is going to be a big number that I don't really want to think about. But that's okay because it's 512. It's equal to negative 9v. Divide by negative 9. Divide by negative 9. If I were to plug this back in, so log of negative 9 times 512 over negative 9, that's base 8, plus 4. Okay, my negative 9's cancel out. Log base 8 of 512 is 3, plus 4 is 7. This is okay too. So v equals 512 over negative 9. For 25, we get a log on both sides. If we only have logs on both sides, we can make sense or make use of the one-to-one property of logarithms, which is pretty nice. What that basically is telling us, if we have a log on both sides, it's just like having an exponential in the same base on both sides. So 2x plus 1 is equal to 3x minus 10. If I bring the 2x over and the 10 over, I get that x is equal to 11. Let's see if we get something that works on both sides when I do that. So we get log of 18 of 22 plus 1 is 23. And on the left side, log base 18. 3 times 11, 33. Minus 10 is 23. Similarly, for 26, we got the same base. So we're looking at negative 4n minus 6 is equal to 5n plus 10. I'm going to bring everything over to the right side for variables. So that's 9n, the left side for numbers, negative 16. So that means that n is equal to negative 16 over 9. When you plug that in to check to see if that's extraneous, we end up with log base 13 of negative 4 times negative 16 is 64 over 9 minus 6. It's 54 over 9. So that would be 10 over 9 in total on the left. And on the right, we got log base 13. 5 times negative 16 is negative 50, negative 80 over 9. And then it's going to be plus 90 over 9. And that's 10 over 9. Hey, it worked. Non-extraneous. For number 27, we're looking at having to use some log properties first. Since I have two logs being added together, I could rewrite this as log base 4 of x times x plus 6, which equals 2. In other words, if I take this and convert it to exponential, so 4 squared is equal to x times x is x squared plus 6x. Bring everything to one side. 0 is equal to x squared plus 6x minus 16. That factors into x plus 8 and x minus 2. In other words, x equals negative 8 and x equals positive 2. Checking these. Log base 4 of negative 8, already a problem, plus log base 4 of negative 2 equals 2. That's not true. If I plug 2 in, we get things that do work out. So x equals 8 is extraneous, and x equals 2 is our answer. For number 28, we've got log base 6 of 9 plus log base 6 of x minus 6 is equal to 4. I'm probably going to combine these things first, and we get log base 6, 9x minus 54 is equal to 4. Let's convert this to exponential. 6 to the 4 is equal to 9x minus 54. 6 to the 4 is going to be 36 squared. So we get 1,296 equals 9x minus 54. Adding 54 to both sides, we end up getting 1,350 equals 9x. That happens to be divisible by 9. So 1350 divided by 9, x is equal to 150. Okay, and just to check, so log base 6 of 9 plus log base 6 of 150 minus 6 is 154, should be 4. So I'm going to combine those two and get log base 6, 9 times 154, I get 1386. Because I cannot subtract, that should be 144, and that gets me to 1296. And we already know that 6 to the 4 is 1296. We have a solution that works.